Welcome to Math with Malia. Today we're doing Savvas enVision Algebra 1, Topic 9, Lesson 3, Completing the Square. After this lesson, you'll be able to use the method of completing the square to solve quadratic equations. For the critique and explain, we have these two students who have solved this quadratic equation. It's the same quadratic equation, x squared minus 6x plus 9 equals 16. If we look at Enrique's work, he moved the constants to this left side, set it equal to 0, then he factored the trinomial, and he factored it to x minus 7 times x plus 1, and then he used the zero product property, split the two factors, the two binomials, set them both equal to 0, and then solve for x. So his solutions are positive 7 or negative 1. For Nadim, he recognized that the trinomial on the left is a perfect square trinomial, so he just factored that as a binomial squared, as x minus 3 squared. It's still equal to 16, and then if you take the square root of a square, that cancels out, so he took the square root of both sides, and he remembered that if you take the square root of a number, you have a positive and negative solution, so then he had x minus 3 equals positive 4, or x minus 3 equals negative 4, and he solved for x, and he got the same two solutions, positive 7 or negative 1. So they're both correct. They're two different methods. What if we had this quadratic equation? We could see that the trinomial here is a perfect square trinomial, so we could factor that to x plus 5 squared. But is 3 a perfect square? It's not. So if we took the square root of 3, it would be difficult. We'd have an irrational number. So Enrique's method would probably work best if we had a different trinomial. It was not equal to a perfect square. So how is completing the square helpful for analyzing a quadratic function? Let's take a look at the instances when we would use this method. So if we have a trinomial, we want to have a value for c that makes it a perfect square. That way we can use our method of factoring it to just a binomial square. So if we know the quadratic term is x squared and we know the linear term is 6x, we can rearrange the tile and we can see that we do have this shape of a square. Okay, it's just missing the lower right corner. So the method of completing the square is just, in a sense, figuring out how to complete that area model. What is the value that will give us this area to complete the square? So if we remember our area models, when we add up our linear terms, so 3x's plus 3x's should be 6x. So all we're doing is we're taking our linear term and dividing it into the two diagonal boxes. So we took 6x and we split it into the two diagonal boxes. So there's 3x in each, so that when we combine like terms at the end, 3x plus 3x is going to be 6x. Well, then if we know that, we can work backwards in our area model. So I know this side is going to be x times x to get me x squared. So x times what is going to give me 3x? Well, x times positive 3. So then I know that each side is going to be positive 3. Then if I know each side is x plus 3, then I can find the area of the missing lower right square. 3 times 3 is 9. I have now completed the square. The constant that will make this a perfect square trinomial will be 9. So c would equal 9. So all we did was we took the linear term, which is b. We took b and we divided it by 2. That would give us what's in each diagonal box. And then we square that, and that would give us c, the value of the constant to make the perfect square trinomial. And you can double check, so we double checked it if our perfect square trinomial was x squared plus 6x plus 9. If we distribute x plus 3 times x plus 3, we would get that perfect square trinomial. So we can check that the constant of 9 would give us this perfect square trinomial, and it would be factored to give us x plus 3 squared. This method is called completing the square. So you'll want to remember this strategy. Take the linear term, cut it in half, That's all you're doing, is you're splitting it into the two diagonal boxes of your area model and then square it to complete the square, or to get the lower right square of your area model to get the constant. So first, let's just think, what is the value of c to complete this perfect square trinomial? So we're going to look at the linear term. What is b? b equals 12. If I cut it in half, that means I'm going to split it into my two linear boxes, my two diagonal boxes. So b over 2 equals 6, and I square that. C would equal 36. And I'll show you in the area model if this helps. So I have x and x, or I have x squared, and if I take 12x and I split it in two, I know there's going to be 6x in each diagonal box. Okay, and then I'm going to just work backwards in my area model. X times x gives me x squared. X times positive 6 gives me 6x. And now I can find the missing square. I can complete the area model. I can complete the square. 6 times 6 is 36. So that's the value of the constant. Either way works. If you want to remember this formula, or if you want to do your area model, you can also do that to find the value of c. Let's do part B. Take the linear term, 8, divide it by 2, and then square it. So it will give us 16. And again, I'll show you the area model, why this works, why it's called completing the square. I have x squared, and 8x is my linear term when it's combined, so that means if I just split it in half, my two diagonal boxes will be 4x each. Then I'm going to work backwards in my area model. X times x gives me x squared. X times positive 4 gives me 4x. Now I know 4 times 4 is 16. My constant is going to be 16. So now if we have a trinomial set equal to 0, how can we solve it? Well, if we look to see, is this a perfect square trinomial? So if I take 16 and I take the square root of it, 4, will I get negative 14? Well, no, I won't get negative 14. I'll get negative 8x's. So how do we get negative 14? This is not the right constant. It's not a perfect square trinomial. So what we can do is we can do what's called completing the square, and we're going to move the constant out of the way and, in a sense, leave a blank space for c to find the constant that does make it a perfect square. So I like to write it like this, plus something. And then if I move the 16 to the other side, it becomes negative. Okay, now I'm going to use my completing the square method. So I take my linear term, b, and I divide it by 2, and then I square it. So negative 7 squared is 49. So I know the constant that is going to make this a perfect square trinomial is 49. Okay, if I factored that, it would be negative 7 on each side, and negative 7 plus negative 7 would give me negative 14x's. Okay, so now I have completed the square. I have found the constant to make it a perfect square trinomial. Now I just need to figure out, if I added 49 to this side to keep the property of equality, I also have to add 49 to the other side. So this is important. Don't forget this. Whatever we do to one side of an equation, we have to do to the other side of the equation. So I added 49 to both sides. And now I can solve. So now we have x squared minus 14x plus 49 equals 33. And now I can factor my perfect square trinomial. I know it's going to be x minus 7 squared equals 33. Now I like this because what can I do? If I have a binomial squared, I can take the square root of both sides. So then I'll have x minus 7 equals positive or negative square root of 33. And I just have to add 7 to both sides to get my solution. So x is going to equal, and this is how you can write it. Put the constant first, and you're either going to add the square root of 33 or you're going to subtract the square root of 33. So you can write it like this, or you can write it separately like this. And then if you want an actual value, you would just do 7 plus and then do the square root of 33 on your calculator and get an estimate for your decimal. So we use completing the square to turn it into a perfect square trinomial. We have to get the constant that's given out of the way, so I like to leave a blank here. And then don't forget, you're going to add it to the other side as well to keep the property of equality. So let's solve by completing the square. Part A, x squared plus 10x minus 9. It's not a perfect square because it would be x minus 3 squared, and negative 3 plus negative 3 will not give me positive 10. So I have to move that constant out of the way. I'm going to move the negative 9 to the other side, and I'm going to leave a blank. So moving the negative 9 becomes a positive 9, and actually I'm going to just leave a blank on the other side too because I know I'm going to add something to both sides of my equation. And now I take b divided by 2 squared. So 10 divided by 2 is 5. 5 squared is 25. So I'm going to add 25 to both sides. Now I have a perfect square trinomial. Okay. And I'm going to factor that. So this becomes x plus 5 squared. There's my binomial squared. Double check it. I'll have a 5x plus a 5x. That gives me 10x. Equals, don't forget to add your 25. So this becomes 34. Then I can take the square root of both sides. X plus 5 equals positive and negative square root of 34. And then I'm going to subtract 5 from both sides. So x is going to equal negative 5 plus or minus the square root of 34. Okay, let's do part B. Again, I need to move that constant out of the way. It's not a perfect square trinomial. 6 is not a perfect square. So get it out of the way and don't forget to leave your blank space because you're going to add a constant to both sides. And now I do my b over 2 squared. So b is negative 8. Negative 8 divided by 2 is negative 4. Negative 4 squared is positive 16. So that's the constant that makes it a perfect square trinomial. I add that to both sides. Now I can factor. It's going to be x minus 4 squared. It's minus because my middle term is negative. Equals 22. Take the square root of both sides. X minus 4 equals the positive or negative square root of 22. And then I'm going to add 4 to both sides to solve for x. Put your constant first. Don't forget your plus or minus. Square root of 22. Example 3, our application problem. The hedge maze has a 2-yard wide walkway around it. So this is 2 yards. This is 2 yards. This is 2 yards. This is 2 yards, all the way around. What are the dimensions of the maze? So I want to know the dimensions, the length of this and the length of this. Okay. What did they tell us? The length of the hedge maze is twice as long as the width. So let's call this side W. That's my width. So the length is going to be 2W. Okay. And it says the total area. So in the middle, I'm going to write 5,616. That's the total area. Okay, so if I know area equals length times width, right? But this is the total area of the maze and the walkway, the whole thing. So we've done this before when we were looking at our picture frames and the picture inside the frame. So our area, 5616 equals, now what's the length? The length is 2W plus this 2 and this 2. So we have 2W plus 4 is my total length. And my total width is going to be W plus this 2 and another 2. So my width would be W plus 4. Okay, and then we can distribute because we need to solve for W. So then we're going to do 5616 equals 2W squared. I'm distributing in my head a little bit, so write out your area model if you need to. But 2W times 4 is 8, and plus another 4 is 12. W plus 16. Okay, so I've distributed. Okay, I can divide everything by 2. So I'm going to do that. I'm going to divide everything by 2, simplify my equation a little bit, and then I'm going to order it in standard form. So I'm going to have W squared plus 6W plus 8 equals 2808. Okay, now I can see I do not have a perfect square trinomial. 8 is not a perfect square, so I need to move it out of the way. I'm going to subtract 8 from both sides, and I'm going to complete the square. So that means I'm going to add a constant on both sides. 2808 minus 8 is just 2800. But don't forget, I'm going to also add a constant to the right side as well. Now, looking at my linear term, divide it by 2. 6 divided by 2 is 3. 3 squared is 9. I'm going to add 9 to both sides of my equation. And now I can factor. So w squared plus 6w plus 9 is going to be w plus 3 squared equals 2809. And we know the rest. We're going to take the square root of both sides. W plus 3 is going to equal the square root of 2809. Subtract 3 from both sides. That's a positive and negative. W equals negative 3 plus or minus the square root of 2809. You can get an estimate if you calculate that. So if I take negative 3 and I subtract the square root of something, I'm going to get another negative number. So I know that my negative answer will not be applicable to this real world situation. So it's only going to be the positive version. So if I do negative 3 plus the square root of 2809, I get exactly 50. So the width is going to be 50. W is 50. That means the length of the maze would be 100. And what's the total length of the walkway? Well, the total length would add 4, so it would be 104 going this way, and it would be 54 width, the total walkway. So all of that we could do because we completed the square. A maze and walkway with the same total area, 5,616, has a walkway that is 1 yard wide. So now instead of being 2 yards wide, we are 1 yard wide. What are the dimensions of this maze? So again, I'll draw the picture really quick, the diagram. Remember it said it was W and the length was twice the width, so it'd be 2W, but then our walkway goes around it. And instead of being a 2 yard walkway, it's only 1 yard, so we're just adding 1 to both sides. So it'd be 2W plus 1 is 2, and the width would be W plus 1 on each side would be 2. Okay, so there's the dimensions. And the total area would equal 5,616. So now we can distribute so we can get our quadratic equation and then complete the square. So 2w times w is 2w squared. 4w plus 2w is 6w plus 4 equals 5,616. I'm going to divide everything by 2. So w squared, which is just multiplying by 1/2. W squared plus 3w plus 2 equals 2808. Now we're going to get rid of that 2, that constant. So I'm going to have w squared plus 3w plus some constant equals 2806 plus that constant. B divided by 2, 3 divided by 2 is 1/2. 1.5 squared is 2.25, so I'm going to add 2.25 to both sides. So now I'm going to have, it's w plus 1.5, or that's fine, we'll say 1.5. 1.5 squared equals 2808.25. And I'm going to take the square root of both sides. I'm going to move on up here. Square root of both sides, so w plus 1.5 equals the positive and negative square root of 2808.25. And then I'd subtract. So it'd be negative 1.5. I know I can't subtract another number and have a negative width, so I'm only going to add. The only viable answer would be adding the square root of 2808.25. And if we do that calculation, w is going to equal approximately 51.5 yards. And then you can get the length, double it, so it'd be about 103 yards for the length. So what's important here is make sure you do this step where you divide by 2 before you do the constant, before you complete the square, because then you'd have to think you're taking the square and dividing it by 2, which is dividing it by 4. So it gets complicated. So if you're going to simplify your expression, do it before you move the constant, if that makes sense. Because you could get the same answer, but you would have to take your constant, you'd have to take the value of c that you would calculate to complete the square, and you would, in a sense, have to divide it by 1/2 squared. Or multiply it by 1/2 squared. Example 4. Using completing the square to write a quadratic function in vertex form. We love vertex form because then we can easily graph. So let's try that. here's our quadratic function, x squared minus 8x plus 11. So we're going to move the constant to the other side. Okay. And then we're going to complete the square. So b is negative 4. Negative 4 squared is positive 16. We added it to both sides, so don't forget to do that. We've completed the square. Now we're going to factor. So x squared minus 8x plus 16. Since my linear term is negative, I know it's got to be minus 4 squared, this binomial squared. And then do the math. Negative 11 plus 16 is 5. And now I want it to look like an equation, right? So just move the constant back over to the other side. And now we have this equation, which can be a function, or f of x equals x minus 4 squared minus 5. And now we have our equation for the function in vertex form. I have my h and I have my k. So I know now my vertex is going to be at 4, negative 5. And I can graph that. And then we learned in a previous lesson how to find the axis of symmetry and how to find the x value for the axis of symmetry. So then we could also graph our function. So here we go. Notice it's not equal to a constant right now, but we want to make it a perfect square trinomial and factored. So let's move this constant out of the way because it's not a perfect square trinomial. That means I'm going to have y minus 3 equals x squared minus 2x. And now I'm going to complete the square, so that means I'm going to add a constant to both sides. B is negative 2. Negative 2 divided by 2 is negative 1. Negative 1 squared is positive 1, so I'm going to add positive 1 to both sides. And now I just simplify, so I can write negative 3 plus 1 is negative 2. I can factor my perfect square trinomial. It's going to be x minus 1 squared. And now just move the constant back over to the right. So my function is going to be y equals x minus 1 squared plus 2. What's my vertex going to be? H comma k. It's already negative, so 1, 2. All right, let's do part B. I want to move that constant. It might look like a perfect square trinomial because 25 is a perfect square, but if I do 5 plus 5, I do not get 6x's. So that's not a perfect square trinomial. I need to move it out of the way. That means I'm going to have y minus 25 equals x squared plus 6x. And I know I'm going to add a constant to each side as I complete the square. My linear term is 6, so 6 divided by 2 is 3. 3 squared is 9. I'm going to add 9 to both sides. And now we just simplify. Y negative 25 plus 9 is negative 16 equals, I can factor this, it's x plus 3 squared. And then I'm going to move my constant to the other side. My function will be y equals x plus 3 squared plus 16. So where would my vertex be? Opposite h, negative 3, k. Another application problem. Astronauts train for flying in zero gravity using a special plane that flies in parabolic arcs. So it goes up really fast and then comes down really fast, and then they start to feel like anti-gravity a little bit. The graph approximates the altitude A. The graph shown approximates the altitude A in meters of a plane in relation to the time in seconds during a training section. So it's measuring the altitude or the distance above the ground, okay, and it follows this equation. We have to answer what is the maximum altitude reached by the plane. So we need to find the vertex. That's what we're looking for. And really we need to find k. That's what we're solving for. What is the y value of our vertex? So if we look, it's not a perfect square, so we need to move the constant to the other side. We get a minus 9,000. Then we want to factor out the 5 so that we have no coefficient in front of the t squared. So if we factor out the negative 5, then we are left with t squared minus 16t, because negative 5 times negative 16 gives us 80. Okay. And then we're going to do our completing the square. So if we're adding a constant to each side. okay? But what's important is we're actually adding a constant and then we're also multiplying it by 5. So it's helpful to put the whole thing in parentheses like that. Okay, so whatever we're adding on this side, the constant to complete the square, then we also have to multiply it by -5 before we add it to the other side. Okay, so b is -16. -16 divided by 2 is -8. -8 squared is 64. So I'm going to add 64, but I'm also going to multiply it by -5. So that's what we're doing over here. Then we're going to add -5 times 64. Because we're completing the square inside the parentheses, we still have this greatest common factor outside. Then we can factor our trinomial inside the parentheses, so it's going to be t minus 8 squared. Don't forget to keep that greatest common factor outside. Don't lose the -5. And then we get -9,000 minus 5 times 64 gives us -9,320. We're going to add that to both sides. Just move it back over to get it in vertex form. So then we're going to have the altitude equals, again, I didn't lose my greatest common factor. I still have my -5 times t minus 8 squared plus that constant. Okay, so this is in vertex form. What's the vertex going to be? 8, 9320. What's the k value? What's the y value at our maximum? It's going to be 9,320 meters above the ground. And when does it get there? It gets there after 8 seconds, because that is my x value. So this one's just a little tricky. If you have a coefficient in front of your quadratic term, you factor it out, and then you're still completing the square inside the parentheses. Just don't forget, the constant you add to the other side is also multiplied by that greatest common factor that you pulled out of the parentheses. So just one more extra step to be careful with. Try it number 5, find the minimum value. So looks like it's going to be a downward facing parabola. Find the minimum value of this function. Okay, well, I don't see a downward facing parabola, but let's see what happens. First, we need to move the constant to the other side. Okay, so we can complete the square. So now I'm going to have y minus 105 equals 7x squared plus 168x. Okay, and since I have this coefficient in front of my quadratic term, I want to factor that out. So I'm going to factor that out. Y minus 105 equals 7 times x squared plus, so what's 7 times, what gives us 168? 24 x, oops, I'm not going to close the parentheses yet, plus some constant. So remember, I'm completing the square inside the parentheses. I still have this positive 7 there. So that means whatever I'm adding to this side, I'm going to go ahead and write it 7 times whatever that constant is. I know I'm still multiplying it by 7. My linear term is 24. So 24 divided by 2 is 12. 12 squared is 144. I'm going to add 144 to both sides and also multiply it by 7. And now we can simplify a little bit. So then I'm going to have y plus 903 equals 7 times, now I can factor this perfect square trinomial inside my parentheses. It's going to be x plus 12 squared. And then I'm going to move this 903 to the other side. Y equals 7 times x plus 12 squared minus 903. I feel like if this were going to be a minimum, that this should be a negative. So either this is a typo and it should say maximum, or there's a typo and there should be a negative in front of the 7. But we have it in factored form. And so where is our vertex going to be? It's going to be at negative 12, opposite h, comma, negative 903. So the y value is going to be at negative 903. We made it to the concept summary for completing the square. So remember, you can use your area models and just find the missing lower right box, if that helps. Remember, you take your linear term and you're just splitting it into the 2 diagonal boxes. So just split it in half. Or if you just want to remember the formula, you take b divided by 2 and you square it and you'll get that constant. Don't forget to add that constant to both sides to keep the property of equality. Then you factor. then you solve, and you can leave your answer with a plus or minus. Or you can write it out in 2 separate solutions. If you have any questions, put them in the comments. Make sure to like and subscribe, and come back for lesson 5.